And now we're going to move on to our last speaker. I have the pleasure of introducing Patty Mabry, who'll provide final reflections from today's discussions. Patty is an interdisciplinary scientist at HealthPartners Institute, where she applies systems-oriented research methodologies to a variety of topics, including issues in healthcare, the biomedical research workforce, tobacco control, and health disparities. Welcome, Patty.
Hi. I'm going to talk to you today about the reflections on using systems science applications to inform the Obesity Solutions workshop. So I want to go back to a couple of questions real quick that came up during the other discussion period, because I did want to mention, someone asked about sugar-sweetened beverages. I would say look up Steve Gortmaker and Claire Wong. They did some work on that. As far as the K-12 education, as far as how early can we start, I think George Richardson has done some work in that, and probably others. I think the System Dynamics Society had a whole thing on K-12 education and systems thinking. And I think there's someone else, and I can't remember his name, that has something like that in I thought it was through museums or something, in network science. And then as far as these broader education, and that these different camps of nobody teaches, I think, Doug, you said no one's really teaching all of these methods in one place. I can talk about that a little bit later, and it'll be part of this talk. So thank you for bouncing the ball over to me on that one. Okay, so here's a reflection. I was actually advised beforehand to be very careful about my images, because we don't want to portray anyone in a light that says, you are your disease, right? So I didn't want to portray this as anybody in my slides without consulting the Rudd Center, who has approved slides for obesity, which I did, but I couldn't find images that were going to work. I think the slide deck there is great. It's just not big enough. So maybe that would be one tip to the Rudd Center. Can you put up more images, please? They didn't say anything about using animals. And so I have some animals in my talk. I'm not trying to portray anyone as an animal. I'm really just trying to use this as a way to say we need to look at ourselves. So it's reflecting on us. And there's a lot of reflecting we're going to do. In fact, I almost had this as my title slide. Pogo, we have met the enemy and he is us. It's from, I think, like the 1970s. But this is really helpful. This is what we're going to be doing here. This is a possum, actually, Pogo, for those of you who are not familiar with him. And we need to look and see what is it that we're doing and make self-correction. And that is a huge thing, I think, that we need to do to be able to make progress, not just in modeling, but maybe in life, right? So here we go. I'm going to give you some highlights. They're all good. Everything here I heard was excellent, right on point, and I'm so thrilled. Doug, you mentioned, interesting to see what's going on 10 years later. Very interesting for me to be in attendance and see, this feels like old home week to me. I just love seeing all these people and just seeing how much fantastic progress has been made with the engagements of policymakers and just the maturity of the models now and what everyone's doing. But I am going to give you not only what other people have been doing in my highlights from this workshop today, but also I'm going to give you the plus. The plus is wherever I see it, I'm going to add something in there that wasn't covered. And believe me, so much was covered there. There wasn't a lot of territory for me to go after, but I still was able to do that. So I'm trying to build on other people. So here, and I know, Doug, you gave a whole other presentation that included networks and agent-based models, and talked about the work with Ross Hammond and doing your Tobacco Town and all that. But I just didn't want it to get overlooked here, that networks is in here. And I wanted people to be aware that this is a really great slide. I really like this slide, Jack, because you kind of boiled it down into, made it easy on one slide. You could fit all this different stuff, which is kind of amazing. At the same time, there is a whole field of network science. And even within network science, there's subfields of network science, right? So there's the people that are social network science people that came out of sociology. And then there's the network science people that are maybe more new to town. And these are mostly physicists. So I think this kind of goes to one of some of the struggles. I think when I say look in the mirror, we need to look in the mirror at the present, but we also need to look in the mirror into the past. And maybe it strikes me that a lot of people may not know our history. And one of the reasons that it's difficult to have all of our training in one place is that what has happened is system science is really, I think Bruce said, a really new thing still. And it came from a whole bunch of other areas. And all these camps grew up, I call them camps, I'm not sure what to call them, came out of their own place, right? So you have the people that called it complexity science and complex adaptive systems. It came out of Santa Fe Institute. You have the whole tradition of system dynamics modeling. You have a whole nother tradition of microsimulation. And these people don't necessarily talk to each other, not because on purpose, but just because that's where they kind of came out of, right? And so to knock down these silos, there's a lot of work that still has to be done. But I think we're closer than we were. We still need to do it. Anyway, so network science, I think I'll leave you with these slides, but there's a whole tradition of network science, including this dynamic network analysis, and how it differs from social networks, and this that gets into very complex things. And if you really look deeply at this diagram up here, you can see there's different types of nodes. There's, different colors. There's also different shapes, and each one connoting a different type of entity. And then the relationships between them can be different. And so it really, yes, Doug, gets really complex really fast. Okay, Jack also talked about this wonderful piece about the time machine, his blueprint for an ideal well-funded project, which was great. I would say another big piece is educating the model consumer. And we talked about that a lot today. And this would be, there's different types of education needed for different people. I think David Mendez, you hit on this, was saying there's, an aspect that's the technical details of how to put together a model, which is very different from teaching, kindergarten systems thinking and, interconnections and processes. But sometimes what can happen when you get a consumer, and that could be a policymaker or whoever else you have on board with the modeling, a decision maker, they can get really excited about it and they want to use it for prediction. And of course, we've heard, all about how we should not be necessarily using them for prediction. And especially the further out you go, Bruce made the point about the budgeting, the further out you go, the harder it is to get the certainty in your model, the confidence. So we've got to teach people about confidence in models, not that they're, right or wrong. And also people, if they drink the Kool-Aid and they do want to use the model, they try to start using, it's like a hammer and a nail, right? If you got your hammer, everything is a nail. And that's kind of what ends up happening. And I think Bruce, too, cautioned us against that, his remark about agent-based models. We don't want to just use an agent-based model because we feel like it. Use the proper tool. And I do believe that we need training across all the different types of modeling. Someone who's not in this slide deck, but who I greatly admire is Kim Thompson. And she has done these models with polio. And you'll have to read her work. But I really like her because she doesn't subscribe to any single modeling. She just knows what the right modeling is. Anyway, and this diagram down here is just that when we educate people, we have to remind them the model. This says if you can read French or if you can read my small writing there at the bottom of the slide, ceci n'est pas un pipe. I don't know how good my French is, probably not that good, but I think it says this is not a pipe. And what that means is this is not a pipe, it's a picture of a pipe, right? And so we have to always remember our models are not reality, they are reflections of reality. And this point was made. I was so glad to hear Jack say it because you got to have it in every modeling symposium. You got to say that all models are wrong and some are useful. And you got to say the parsimony thing that keep your model as simple as possible, but no simpler. And so this gives us enough of an idea of what a pipe is to know that it's a pipe and to have it for the utility of looking at it to convey the idea of a pipe without actually it being a pipe that we can smoke out of, right? Okay, so Jack, oh, no, I'm sorry, this was Project Play, talked about the synthetic population that they use building the census data. And I thought, wow, this is a good foray into all these secondary sources of data. So I think that was one of the things I was asked to do, is provide some resources for people. So I will provide my slides as I always do, and you can go back and look at all these different things later. But I think that it is important to know that in some cases, it's going to be very useful to know where these synthetic data are that we can use to populate our models, because it'll save us a lot of time and trouble. So one place is this synthetic world population for agent-based simulation on Figshare. There's another one that RTI has done. I'm not sure if that's the one you used, Bruce, but that was part of Midas put that together, so NIH dollars. Social Science One, I haven't checked that in a long time, but that was data from private industry. The next one that I found out about maybe a year ago is MITRE paid for this one. It was paid for by the federal government. So MITRE is an FFRDC, the Federally Funded Research and Development Center. And I'm not sure who paid them to do it, but they've got this thing called synthetic mass, realistic but fictional residents of the state of Massachusetts. And so I think it's really helpful because it's free of the protected health information, but is, could stand in for some of this information. They've got birth and death cycles. So anyway, good, useful for people building models. Another one that we've got now is called All of Us, and I think this is ready for prime time. I know it's not finished, but I believe there is enough data to get you started. I believe that's able to be used. I really haven't tried to use it myself, but I plan to. So All of Us has this research hub, and I highlighted this part about the health disparities, and they're collecting a whole bunch of data on many different things, behaviors and diseases and biological samples. And so really a wonderful place to get data for any of your models that would be across many of these levels of analysis that we talk about. This is, let's see what else they have. Oh, this I wanted to mention, robust electronic health records. Don't ask me how they're doing that, but biospecimens and electronic health records was enough to get me very interested. Jack mentioned the need for longitudinal data. That's huge. And I think one of the reasons we don't have so much of it is it's hard to collect. And so anytime you see a longitudinal data set, you should go for it. I think we know about AdHealth, and that's a great data set for a lot of things. I don't know if this one compared to AdHealth has the social network component, but if it did, that would be awesome. They're trying to get 1 million people sampled into this study from all across the country, and they've got, I think, 270,000 now. 330,000 have agreed to participate. So go check it out. I'm excited. Okay, the Aspen Institute Project Play also talked about each agent being embedded with this personal metabolic model. I love that. And I noticed that you cited Kevin Hall, and I just wanted to call people's attention to Kevin's model. I think it might have been used also in a model that Jack cited that was by Sadia Falafini and Hajir Ramandad. And so here it is. It is a paper from the Lancet. They developed and validated a mathematical model of childhood energy balance. So to the extent that we can, we should reuse models when it makes sense to. And I think in this case, this is one that can be reused and is a really good model for that, for the purpose that was used for it. And it should be good for some of your work too. This one is from the Communities Baltimore. And I try to pick 2 slides from each talk to kind of highlight. And this one, I think I really liked it because it shows us the importance of spatial models. And I don't think anybody really explicitly said this. Now, perhaps this was covered, back when the agent-based models with Ross and Doug were talked about at a few workshops back. But this is really important to understand inequalities. We have to understand the spatial environment. It's not enough to just use race or age or other demographic characteristics. I think we really need to understand the food environment and the exercise environment. So I was really thrilled to see these spatial aspects. And do I have something else on that? Yes. On the next slide, I think we also saw something over here from the, and I've heard it pronounced different ways by all of you. I was listening carefully. I think it's Salud Urbana, but I think the short name is Salubra. I don't know. Anyway, I apologize if I'm pronouncing it inaccurately. But I also noticed that you had the spatially explicit model. I think this is going to be more, I think it is very important for understanding health disparities in obesity. So we should put that on our list of things to do. It'll come back later too. So why we need systems approaches for community settings. I picked this up from, I think Bruce, wasn't this your talk? I guess this is the Baltimore Communities one as well. And I liked how it had all these different, there's a nice way to convey in a picture. So remember, a picture is a model. It's a model of how we're all working together across different sectors. And I liked that depiction. But I would say what I didn't see here, which we would like to see, is some other things as well. And I realize you can't put it all in because remember, make your model as simple as possible, but no simpler. So here's some other things just to consider. I mentioned the spatial, there's temporal properties, there's network structures that one reflected, there's hierarchical and nested structures, there's feedback loops, there's individual variation, group level, and I'm sure I didn't even capture them all on this slide, but I was trying to say yes and. So this is a way that I've depicted it. I think I saw someone else had a very similar slide in one of their slide decks that they took from Glass and McAtee from 2006. This one we kind of colorized and did some different things to it. But I liked how it shows not just a timeline, but specifically lifespan. So it's lifespan, but it's also time. And those are kind of related but different. So you could have something that goes over time just to see how a process plays out, but you might be capturing people at different points in their lifespan. Okay, across that. So when we look in the mirror and we say, what could we be doing better? What are our reflections on ourselves? What do we need to be doing? We have to look at the fact that humans are humans. And I'm trained as a clinical psychologist. So there's nothing I know better than people's behavior. And people, being people, will oftentimes take a shortcut, an easy way out. And I think that happens with complex problems. And that is why we do not always solve the complex problems, because it takes hard work. And I can't remember who said it, and I don't remember if it was from today or one of the previous workshops, that someone talked about a simple solution to a complex problem just doesn't work. So we have to figure out what are the complex solutions to the complex problem. Why is it so hard? Well, first of all, opportunities are usually disguised as hard work. So most people do not recognize them as opportunities. That's Ann Landers. I used to love reading her when I was a kid. She was an advice columnist, for those of you too young to remember. And this came up for me. Why do we go for this? See, the guy's reaching for the apple. Which one is he going for? He's going for that low-hanging fruit. And I would give you $1. Well, I don't have that much money, but if I could, I would give you $1 for every time I've heard somebody say, oh, let's go for the low-hanging fruit. It's this. Okay, so by definition, pursuing low-hanging fruit is a no-brainer. For, in this case, it was written for someone about business. It's an easy opportunity. It's just waiting to be seized. You don't have to do hardly any work. You just get all the reward for it. But that's just not how most of these, especially complex problems, work. So we need to go for the hard part, okay? So this is someone I greatly admire. I've never met her, but I wish I had, Dana Meadows, and she wrote this great book. And someone asked about this earlier. Someone mentioned to it, I think Stella, you referred to, I think it must have been her book about what everything is a system. Yeah, I think that's what she talks about in the beginning of her book. The person who asked in the comments field, where should we start? What if we're new, where should we start? And the happy hour method, Bruce, is a great way. Another great way is to open this book. And it's a great one by Danella Meadows. And in it, you should go to, I can't remember the page number, but it is chapter 6 in the book. If you do nothing else, just read this chapter. It talks about the easy places to intervene in a system are going to get you the least return on your investment. The hardest places to intervene in the system get you the most return on your investment. And I think, Anna, you were talking about this in your presentation today, and I was very impressed that you were coming up with some of these harder areas in the system, right? I think you were talking specifically about how folks are incentivized in some way in the system. The information that you were getting out of the system was going to help change behavior. So anyway, give it a good read. What else makes modeling so hard? Well, we've talked about many of these things. It's getting good sources of data, and people say, oh, garbage in, garbage out. But I agree with the people that have said today that modeling is a way to organize your thinking and help formalize what you got there and see what you got and what you're missing. But this longitudinal data is important if you can get it. Stakeholder engagement. We've talked about it with policymakers, healthcare systems, businesses. It's a crucial part, but it's also hard work. And this is where you all said it takes 10 years, it takes 15 years. And yeah, it's worth it. But come on, who's going to go for that? It's going to take special people and special funding maybe. We're also impatient. And I think this is back to somebody mentioned the policymakers. They have a certain time in office, right? So they want to get something done. So that was, I think, given a reason for why they might focus on infectious disease, because it's acute, right? You get a pandemic, it's broken out now, everyone's dying now. Chronic diseases, that can wait for the next administration. Interdisciplinary team building, this is kind of my specialty. It is very hard. It requires communicating across disciplinary boundaries, but there are people like me out there. So find them. There's a lack of self-efficacy. I think we rely on what we got educated to do. And I learned everything I know about modeling on the job, digging around. So you have to develop that self-efficacy. There's also a culture of worshiping the RCT. And believe me, I worship it too. It's a great gold standard, but it just isn't, it's not going to solve everything. It's that hammer problem, right? Not everything is a nail, and we can't use our hammer on everything because it won't go into small spaces or, do the things that we need it to do. Following through on a course of action that models indicate can go against ideology. Look at just things like social distancing. I don't want to hit any hot buttons, but right, if a model says you should do this, then people are going to say, well, no, we shouldn't. And I think this came up today, even with, wouldn't models, get these stigmas going and so on. We got to realize that the models are the models, and they just tell us some information, and we can make a decision whether we agree or disagree with the model. Okay, there's my timer to let me know I'm nearing my end here. Okay. Then there's also a prevention conundrum, and it's really difficult. Even when our models show, Bruce, you showed in one of your models, it saves billions of dollars to make these investments. I think it might have been Project Play, or I can't remember if it was the other one. And it's going to save billions of dollars, and not just for this cohort of kids, but for the next cohort and the next cohort. And I'm thinking, that's fantastic. And then I'm thinking, it's so hard to convince people because they didn't feel the pain, right? They didn't feel the pain of paying those billions. So you aren't actually going to give them billions back in cash. So it's really difficult to prove that your intervention that was recommended by the model actually is avoiding the impending doom. So when we think about putting together our teams, I like to think of myself as mortar between the bricks, right? And other interdisciplinary scientists. I think we need people. I mentioned health geographers or people that know how to get spatial information into models. That's important. Modelers being the technical modelers. I'm talking about the simulation modelers, policymakers. All these people are important. But don't forget about the mortar between the bricks. You can't build very well with just the bricks. And we need our deep people that know their specialty. But we also need people that can talk across these disciplinary boundaries. We also need community members. And I know Peter talks a lot about this, and I know the group, I think it was Salubra, used Peter Hoffman, and I'm sure he talked to you about the value of the community members. But sometimes that gets overlooked, and we go straight to the policymakers and some of these other organizations, and we don't really get the perspective of community members, and that's important. Okay, I think we have just a couple minutes. I wanted to mention Phoenix Toolkit that has social determinants of health in it. It's a good way to get some measures, other sources of data on social determinants of health. Most of these data are at the aggregate level. We need data at the individual level. And I know that healthcare companies like ours that have electronic records are trying to get the social determinants of health in there, but there are issues with that. Okay, I don't have time to go into all of these. I wish I did, but Bruce, I wanted to ask you, is that ABM available for reuse? Not to put you on the spot, but we do need to be able to share and reuse, and it seemed like you were hinting at that. I know you were saying that it could be used for different purposes. You have to be careful about repurposing your model, make sure it fits the new research question and the new research population, or do you have the appropriate data to go into it? But okay. More additional resources for the people who want to get started. This is for you. I regret I don't have a link for this NIH Institute on System Science and Health. The reason is it was not 508 compliant, and therefore that means that it was not able to stay up on the website. So I have all these wonderful resources, tons of them, great people, icons of the field, and it was all taken down. I actually still have the files. So if anybody has money to pay for captioning of videos, then we can put it back up. I think I could not get it from NIH, and I'm not there anymore. So I guess I can't be the champion. Okay. Oh, sorry. Sturman's article, Envision, helpful. This is the book by Donella Meadows, Thinking in Systems, a primer. You should get it. You should read it. It's so accessible. It's just great. I also wanted to tell people you might not know about Cypher and about CSART. And Cypher is also funded by the Wellcome Trust, just like Salubra. And it is a group that's pretty new. I'm on their board of advisors, and we haven't even had our first board meeting, but it's getting on a year now. I think COVID kind of up some of the plans. So look at that, because it's going to look at 4 interventions and deliver cost-benefit systems modeling, cost-benefit evidence on cross-sectoral health problems, including mental health. Okay, this one, CSART is a nonprofit. I'll let you read that. I didn't know you all had short courses, so I put those down, but I could not locate them just on the fly here today. But good that you have those. Please send them to me, Anna or someone from Drexel. Future directions, lots here, but I think mostly one that we need to do is, build a community of system science. And that's how we're going to get stronger and better and be able to do all the other things that we want to do. We've got to build a community. And I was trying to do that from the inside of NIH. I think I hope I was successful. I'm looking out today and feeling like I was. But we need some kind of like our own society or something to bring in all the people, the ABMs, the system dynamicists, the microsim people, just like we need them all. And we need to get together and we need to kind of help, because we need funding for one, and it's going to be non-traditional, right? We need funding for our education. We need funding. I think we should use the funding to inform different research priorities, system science-based ones. We need to form these relationships, all these things that are going to need resources. So I just wanted to give my nod to this Walt Kelly for his theme today on We Have Met the Enemy and He Is Us. And you see Pogo looking out at all the trash on the ground, and he's got to pick it all up, because guess what? He's the enemy and he's got to fix it. And that was for the first Earth Day in 1970. I don't know if I remember the first one, but I think I remember the second or third one of Earth Day. It was a big deal. And Donella Meadows, Dana, founded the Sustainability Institute, so she cared about the environment. So I thought it was very appropriate. So I'm dedicating this talk to the 2 giants, 2 of them. There's many, many, many people, giants whose shoulders I stand on. One is my dad. He died about 3 years ago. A big Pogo fan, a nuclear physicist, and a great dad. And Dana, who I never got to meet, but who's really been a great influence. So thank you very much.
Thank you, Patty. That was amazing. You highlighted so much of what we talked about today. You hit on key points and you filled in some gaps, and your slides are really, really valuable. So I want to thank you for your time and for tuning in all day so you could quickly summarize all of that. We have so much respect for you and all that you've done in the field, and really, really appreciate you spending time with us today.